Good morning. My name is Sanghoon, Yoon, and I'd like to give special thanks to my mentor, Shin, and this is my project. My project is Replaceable Presentation Learning with GAN, and this is about me, and I am currently a master's student in KAIST, and so I'm going to graduate at February next year, so I'm looking for a job, so yeah, please consider. and this is my title of my project, but Sun gave some feedback that it's quite difficult to figure out what it is. So I changed the name, title, the changing clauses with GAN. Wow. So it's quite intuitive. So my abstract is the changing clauses with the images. So my motivation of my project is first I was interested in the image-to-image translation, represented by some CyanGAN and DiscoGAN, pixel-to-pixel. So there is some examples like the chair to car, the rotation, and the horse to zebra. So I found that component is now or can be used for feature conversion as well as the feature extraction. So I found that these results. I found some insights. The encoder extracts common representation like the rotation in these data and the shape of the horse and other aspects also. And the decoder visualized the extracted the representation to the domain-specific image. So I did wonder. What if the two domain has unequal information, or the one domain has total information of the other domain. So if you convert this image to this, it's quite makes sense. And if you want to restore or convert, it's quite difficult, tricky. So because there is lots of possibility. They may be some male, female, or what there would be some face. So we can give some variance by giving noise as a guidance, or we can provide some semantic information. So I wanted to give this information with image. So with this image as a guidance, I try to convert this image to this. I assume that these are the same person. So consequently, it has become a problem of combining two image, or changing a part of image with other image. So I want to define my problem, and let's define some two domains, and A and B. So my project is about the clauses. So domain A is model, and domain B is domain B is clauses, and domain A provides has some more information. So I want to disentangle the representation of XA into CB and GA minus B. And CB represents the closest part, and GA minus B represents the rest of the image. So if we want to, if we can say the CB is replaceable, if we replace CB with GB, it can be generated, I think. So I want to implement these things. So my approach is this, and I got inspired from the CycleGAN. So, but there is some what? So let me explain the detail. And as I said before, I want to encode XA to GA, the latent, and I want to disentangle these representation into CB and GA minus B. And CB represent the closest part, so I want to decode CB into this image. So, it should be some closest image, so I want to give it to discriminator. So I want to, and then the rest of part GA minus B, and then that's concat with GB, and GB is encoded from the other closest image, and by combining them, I want to generate some new embedding. So and I want to decode it into the changed images. So this is my structure of my model, and it's quite. It looks valid, but it's quite difficult. And I can also, adopt some losses. So it's GAN, so we adopted some loss of the discriminator, GAN loss, discriminator, and generator loss. And also, with only this, we don't have a way to maximize the virtual information between these two and these two. So I want to give some reconstruction loss, like CycleGAN did. So here, so by doing this, I want to maximize virtual information between these two and these two and these two. So I adopted the GAN loss and reconstruction loss like the CycleGAN did. So my data is from the deep fashion. So it has lots of model images like this, but it has a small number of images like this, just closest flat images. So I collected additional images from the sites of many sites of apparel brands, and I use Selenium. If you go back, so it's browser automation. So if you want to crawl the data, it will be very helpful. So and the main setting is similar with the CycleGAN. So downsample twice, 9 resonant blocks, and reflection padding. And to prevent checkerboard, I adopted the convolution with NN resize convolution. So, and the input size is 200, 200, and 1 mini batch size. It's also same with the CyangeGAN and other things also. So these are results.
Wow.
So does it look valid or like this? So it's quite good results. But most of results are not good because the size of clauses are too large. So it covered the bottom and also the part of bottom. So it's very hard, tricky to only change these part, top part. And the other problem, it's quite quite bad problem. It does not capture the structure or the color. So it tries, but it's not perfect, and it does not capture at all. So just to change to white. And these are other examples. So it just covered. These are just too wide, so it just covered. And this is also, so it's most of results are like this. And also we need to the model need to reconstruct this image from this. So there is some noisy part affected by this image, and there is some noise, and also there is some noises. So I browsed the results of my model, and they show this the common pattern of failure. If clauses has bright one, it just changes the white to white, and if it's dark, it just covers. So it's very severe problem. So, and it's also failed to convert model to clauses. It's both collapsing or just I think it's just because of the white bar of the it's inherent problem of the diffraction data. It all has the white sidebar. So these background they recognize the background as the closest. So it just generates the same result. So I decided to detect some closest part with detector, and also after the detecting the bounding box, I want to add it as first channel. So I tried to let them know where the closest is. So and also there was some problem of the scale problem. So I detected some bound box, and with considering these box and so resize and shift and depth concat. And also they have some they showed some low mutual information between these inputs and outputs. So I adopted some additional loss which compared the colors of these and these. and this. So I used some faster RTMA for the object detection, and it showed quite high precision. So here's the result. So if box is fit, it tries to these textures, and also these textures are captured, but not perfect. And these logos are on here, and it covers so the result is acceptable when VBox is fit, but most of VBoxes don't fit. So here, and the postures are all different. So they have four arms, and also the shoulder does not match. So, but there are promising results. Like they try to guess the skins, not perfect, but the original image don't have the skin, but it tries to, and it also this. But as you can see here, it does not capture the color, pink, and also it tries to, but not perfect. And by adding forest channel, the conversion, the model to glosses is improved, but like this, it removes the head, bottom, the arms, but it still does not capture the color or structure like the color, and if the clothes are white or bright, it does not capture the clothes. And so here's the discussion. So I did want to figure out why these problems are happening. So I tried by using these reconstruction laws. I tried to maximize mutual information between these two, but it just generates the output that doesn't depend on these images. So because I think it's because of these embedding. This is new part of our model, but I think the gradient goes to this way, not this way. I tried to this way, but it just goes to. So I think the closest part is also go to this part. I was trying to disentangle these two representations, but it doesn't work. So I need some more methods. So here's the other discussion about the representation clauses, because it does not capture the clauses color and the scale. So I think the representation of clauses should be scale invariant and posture invariant. So by extracting those representations, I can convert more perfect images. And also, the ChangeGAN downsamples the input only twice. So I try to watch more, downsample much more progressively, and also the clauses should be not pixel wise. just if the model's posture is different, I think the shape of clauses should be changed. So I think I try to adopt some not pixel-wise loss, but perceptual loss. So and also these are deformable component. It is good at extracting some features, the scale invariant features or rotating invariant features. So I try to use this networks, and also also to remove the these noise. The Gayang yesterday, as Gayang said, she adopted some extra layer, extra output. These are for just reconstruction, but so it has some more information, but noisy output. And these are removed, the noise removed output. So I can use this approach, and also, as I said, the deformable content. So here's the contribution. So I suggested a novel structure of GAN, and also train closely the bebop detector. It has quite high accuracy, and also I collected image of position models, and also implemented some crawler, and there are lots of results. I also need to browse lots of results, so I implemented some web app to browse the results of GAN. So if you want to, I'm glad to. Here's the repo, and actually, I implemented some various modules. There are lots of modules, and main part of it is absolutely my ChangeGAN implementation. And I use Google Object Detection API, so there's only label map and some configs. And there are lots of data set processing tools. So I implemented for diffraction, LMA, and the fraud data set. And also I have for builder for just image, or just or for with bebops. It's not perfect, but you can use it. And there's coroller. So each file has some specific implementation of coroller. Here's the guidance. And also the browser. It's React-based app. So you can browse